All right. I'm live apparently. Hello everybody. I don't know if I can see which folks are here in the chat. I have the chat up, so feel free to send some comments. There's an and we are live. Excellent. So hi all, my name is Casey Hart. I'm going to talk to you today about how ontology drives data agility. Thinking about the conference topic of change, I went to agility. Sort of reflecting a little bit over the past week on what I mean by agility, and I think often as I'm riding my bike around the neighborhood, and there are a bunch of deer in our neighborhood, and I'm struck by how graceful and agile a deer can be, and they like leap over a fence in a single bound. And I'm also struck by how terribly clumsy and unagile a deer can look when it gets terrified of my bike and I'm not a predator, and it runs straight into the fence and bounces off of it, right? And I think in many cases our companies can represent both of those when it comes to handling data. So I only have about 15 minutes to get through this stuff. I'm long-winded and tend to take too long with things, so we'll see if I can rush through it and hit at least at a high level how you can see how ontology might be a tool that helps you be more agile as you deal with your data. Um, from the chat here, I will sort of keep my eyes on it. Please feel free to interrupt me at any point, ask questions. Ultimately, I don't care that much if I get through the slides. I get more value out of sort of communicating to you if you have particular questions. So let me know if there's some term you don't understand or something doesn't make sense, or if I say something terribly false, which is bound to happen. All right, so the plan for this talk. I'm going to give a little bit of background on myself and then on what ontology is at a general level so we can see how we might want to use it as a tool. I'll lay out the problem, which is essentially how can we handle updating and changing data in our enterprise. Then I'm going to use a couple of metaphors. As was probably already obvious with the deer one, I like metaphors. We'll use a couple of sports and chess metaphors to see how we can conceptualize ontology as being a solution to the problems that we just laid out. And I'm going to put out some caveats. Ontologies are great, but they're tools, and you can use any tool badly. I'll be sort of contrasting it with relational databases and relational models. Those are also tools which can be used really well or really badly. I think they're just sort of knowing the right situation to put them in. And then if by some miracle I still have some time, we can talk a little bit about next steps. But I definitely want to open it up to questions near the end so people can let me know if there are sort of what issues you've had, what I've said previously, and there'll be my contact info and whatnot if you want to reach out and talk about maybe some more particular problems to your organization. So, backgrounds. This is me and my snowman and my daughters. We don't get snow that often in Texas, but we had our Snowmageddon last year, so it was a fun place for that picture. My background's in math and philosophy. I sort of found out that I love doing philosophy and math, but I can do formal epistemology and philosophy and get the stuff that I love out of the formalization in mathematics. That sent me to grad school. I went to Wyoming and then the University of Wisconsin-Madison, specialized in logic, epistemology, formal epistemology, philosophy of science. And then instead of going the professor route, because the job market was terrible, to be frank, I found my way into this weird field called ontology, which if you don't know what that is, you'll learn a little bit more about it in the upcoming slides. I didn't know that much about it at the time. I worked mostly in oil and gas domains when I was at Sicor, some defense stuff, a little bit in emergency rooms and in hospitals. And my position there was building the models, but also doing evangelism, pre-sales, those sorts of things. And I moved about a year ago into my current position at Olive AI, where we do healthcare specific artificial intelligence. And here I've been in charge of building that model out and also doing some internal evangelism, less sales things here, but more sort of working on what does the ontology actually look like and making sure the different folks at my company know what the ontology is and how we can use it. And that to that point, we'll sort of be talking about how you can use an ontology throughout the rest of this talk. The domain is healthcare, but when you do healthcare, you have to touch on a little bit of everything. Because if you want to know about a knee surgery, you need to know about knees, which means you need to know what they're used for, which means sports and various other things, right? So healthcare touches on all sorts of domains. All right. What is an ontology? Some of you might have this question. When I talk to people in my company on a daily basis, they often have this question. At a very basic level, it's a language that both computers and humans can understand. in order to express your data, right? So an interface that we can both hit. Looks something like the text you have on the screen. Don't dwell on that yet. We'll get a little more technical later. Slightly more complicated. Ontologies are formal models that represent both the entities and types of entities and the relationships that they have. So you get knowledge graphs and ontologies. I'm going to use those terms more or less interchangeably for this talk, right? But a knowledge graph, because you can write it as sort of these bubbles and edges that connect them, right? So you can have doctor and patient and it connects it, or you can have car and hood and tires, and these things are all connected in various ways, right? Because they're a part of one or attached to the other, those sorts of things. And even more technical, an ontology is a set of n tuples that serves as both the data and the language for expressing the data, right? If you're more acquainted with ontology, you might think that the ontology is just the T box of your triples. I think that's wrong, but that's a more in the weeds sort of discussion at some point. I say n tuples, often we talk about them being triples. So if you see below, you see Chatfield A listing, it's a triple because you have a subject, predicate, object. That's the relationship. But it can be any number of entities. You could have 4, 5, 6. The most common in the industry is to do triples, maybe up to quads when we talk about a triple showing up in a graph as that fourth entity. All right, but a little more abstract because maybe those definitions aren't all that useful, or you would be interested in seeing how they are, what it actually feels like in practice. So here's my daughter, Elizabeth. I actually made this first a year ago, but we came full circle and pumpkins are now relevant again. So it's great that this conference is in October. She's learning to read. She sees some string, pumpkin on a page, right? It's fun to watch her sort of sound it out. And like you get this aha moment where it clicks. Great. Why does it click? What is she seeing? Well, she knows stuff about pumpkins. She knows that they're orange, that you get them at harvest time. They grow on vines in the garden. They get to various sizes. They make delicious pie. Some people think that's controversial, but it's not. Pumpkin pie is delicious, right? They have guts. You carve them for jack-o'-lanterns. She knows all of these things about pumpkins, right? And when she says the word and has the aha moment, it's because, oh, this string represents this concept. And this concept has meaning these sort of richly related to other concepts in her vocabulary, right? This concept and this set of concepts, how they're related to one another, is sort of our human personal ontology representation. And when we're building artificial intelligence and we have an ontology, that's the role we want to play for them. So if we're talking about insurance companies, we need to know there's insurance companies and insurance policies and patients and doctors, and these things are all related in sorts of ways, right? If we're talking about cars, we need to know, well, there's roads and there's cars and there's street signs and there's drivers and there's passengers, and these things are all related, right? We don't take any of these things in isolation. We know that they're all connected to each other in one way or the other. And this is useful because if we get some small piece of data, right, we say he was driving last Thursday. We say, well, he's driving. Well, he was driving something. It was a vehicle, and he was probably driving on a surface you could drive on, right? From a small sentence, we can infer a lot more about these things. We want the same thing with your data, right? We want to see a snippet of your data, but we know that implies a bunch of other things if we really understand it. So I showed this graphic a few slides ago, but maybe now we can say a touch more about it, right? So we know that a Chatfield listing, so this is for like a real estate ontology model. This listing is of a type listing. It's a listing of a particular piece of real estate. This listing has a particular price, and that price has a number and a dollar value, right? It's a US dollar as opposed to a yen or something else, right? We take all of these concepts and we relate them into with one another. And it's a little bit awkward as a human to separate things into these 3-word sentences, but it also parses things in a way that makes it really machine readable, right? And so this is a way that our data can be understandable by both us and machines. All right. Now I've talked for long enough. We want to make sure we hop over and hit the problem. I have so many cool things to say about ontologies. Would love to talk about that more in the future. But let me hop over and say what the problem is and why I think ontologies are well suited to be an agile response to changing data. So you're at some company, right? You have 3 main data sources. You've got stuff in HR, warehouse, and sales. Great. And this data all is related in some ways, right? So we know that things, employees in the HR work in the warehouse, which has equipment that's being sold by the sales department, right? Or specs. So we make some way to tie these things together. You have some data management schema We have lookup tables. We tie these things together so you can write your SQL queries to get the connections that we want to see. But this is the problem. Once you've got that set, things get more complicated. So your company acquires some new other company, and your company wants to be more data minded. So they start a data initiative, right? They add some more data sources. Your tables get longer. We get more tables. Some of your data sources are tribal knowledge that are stored in Google Docs, right? We change our field names. How are we going to handle with this changing data? Well, our schema needs to get more complicated. So now instead of just having 3 sources, we have 5 sources. And you need to be able to interderive things from all of these sources. You need to know where sales joins to HR, which joins to warehouse, which joins to governance data, right? And that means way more connections. You get a schema table that looks something like this, or this. Some of you might say, "Oh, I only wish my schema table were that simple," right? To me, when I see the more complicated versions, I get sort of callbacks to like pre-Copernican drawing a picture of a geocentric universe where you have to make all of the orbits perfectly circular, and it's beautiful, but it's crazy complex. Whenever you find some new observation, to explain it using this model, you have to add like extra epicycles, and things get really difficult. And the problem here is that when you add a new data source, get a new piece of data or new observation that you want to deal with, then it takes a lot of effort to accommodate it, right? Every source needs to get connected to every other. So when we have 5 sources and we add a 6th one, you have to translate that 5 more times. When you get a 7th one, you have to translate that 6 more times. The data architecture gets really complicated, and it gets baked into your applications, right? You get sort of ground into this really complicated schema, and it makes things slower. It's also really tough on analysts because you have a higher burden to be able to solve to write SQL queries or make solutions that depend on your data that's scattered. You probably have this experience where if I'm dealing with such and such a type of data, I have to talk to this person because they know where all the bodies are buried, right? Like, it's just a really weird schema, and you need experts in how the data is structured, not just in what the data means. Cool. Let me give you a couple of metaphors, and then we'll translate how these metaphors look back over to an ontology being a potential solution here in just a minute. So I got into playing racquetball in college. It's a great time to get into it because when you're 20 and playing racquetball, you're like the youngest person playing it. Whereas when you're playing basketball, like at that point, I was like, well, I'm not a good enough basketball player. Like, I'm clearly not a college athlete. But hey, when you're competing against people who are 75, great. So I went to my first racquetball tournament. Played and won a couple of matches, and I played this old guy in the I don't remember what round it was. Got ahead of him a few points, and I started to feel sorry for him, right? You're like, man, I'm just running, I'm diving all over the place. I'm like way more athletic than you. This is rough. And then he beat me in a really embarrassing way where he basically stood in the middle of the court, hit lobs, could control the ball, and I'm chasing all over the place after the ball, diving, and he just like calmly waits for it to come back to him and then hits a cross court and kills it just every time. And it was really embarrassing. Okay. Another metaphor, chess. When you first pick up chess, and some new players often bring out their queens too early. And then new players also get freaked out when someone brings out their queens too early, and they like keep trying to attack it, right? And they don't pay attention to developing their own pieces. So in this case, white was really excited that, oh, I can move my pawn out and I can attack this queen, but they didn't realize that one, their bishop is still under attack, so they're in trouble. And two, this pawn on g2 is still under attack, so they're also in trouble there. They got so like focused on the shiny thing in the middle of the board that they forgot to sort of slow down and develop their pieces like carefully for a long end game plan. Hi, youngling. Welcome. So, moral of these metaphors. Don't always just be reactive to the thing that's, don't chase after the racquetball. Don't just try and develop, attack the queen that's in the middle of the board. The most athletic thing you can do in a given moment isn't always going to be the best thing. In fact, it might slow you down a great deal and leave you in a compromised, awkward position. Instead, you should know the geometry of the court. You should develop in a flexible way. So how does this tie out to ontologies? Well, ontologies model the world. They model the subject matter that you want to cover ultimately, right? And they can be reused and expanded over time. They're not focused on just what your data looks like. They're focused on what your data is trying to tell us about the world. So if my data is telling me about cars, let's model cars. Let's not model the data that's about cars. And we can translate the data into that. Why does that matter? Well, return to our problem picture here, right? We have a changing data landscape where we have a bunch of new data sources. We're trying to interderive things from one another. We have all of these connections we have to make. This gets really messy. But what if we put in the center our knowledge graph, our ontology, our model that's driven by the world? Well, now you just need to translate each data source once, and exactly once, into that central graph. This can be a steadying force, right? So then if you have a lot of motion out here in your data, sort of on the fringes, it's not that distracting because you get an alteration, you change how that fits into the graph, but the graph is focused on what we want to talk about. We want to talk about patient care, or we want to talk about oil and gas, or we want to talk about the stock market. Whatever it is, it stays focused, sort of, isn't eye on the ball, it's eye on the court, knows the geometry of the court, and says, whatever the data is, it's going to have to come to me to talk about the things that we want to talk about as a company, right? This gives you a lot of stability. I'm getting a little later here in the talk. We're around 16 minutes in. I want to make sure I leave some time for questions. We can come back to this this example if you want, but that sort of shows how you can have a query that's driven based on the semantics, based on wanting to know what sorts of questions we want to be able to ask, and it can go out and hit all of your various data sources. That's a stabilizing force. All right, so I'm going to quickly throw a couple of caveats before I ask for questions. You can make ontologies or relational databases in good or bad ways, right? So this model of try not to get focused on the shiny thing or the contingent things because that will sort of leave you off balance. That's true if you're building a relational database. You can try and build them in safer ways that will not leave you as prone to these sorts of problems. You can also build ontologies in really dumb ways that are siloed themselves or look, are very stringy, focus on the data sources, and they won't be able to adapt and change work very well for your data. So don't think just because you're using an ontology, you're going to solve this problem. I will say, though, that because ontologies are more focused on modeling reality, they should be a little less sensitive to changes in your data structure and a little more responsive to getting new data sources because they're grounded in the real world. So there's like that tendency of it, but I've seen plenty of bad ontologies too. So we shouldn't kid ourselves into thinking that that it's a one size fix. So next steps, if you say, man, this resonates with me, we have changing data sources and we have to start from scratch every time and it's really problematic. First thing that you should do is say, okay, what costs am I facing because my data, because my company lacks agility with respect to the data? It might be less than you think, it might be more than you think, but sort of know what those problems are going in, and then talk to somebody who builds knowledge graphs. Talk to an ontologist. Feel free to reach out to me to see if your enterprise is going to be better off having a knowledge graph as some way to sort of anchor you, keep your feet set, and be more responsive to changes in data. You can look and see if there are open source options. There are some decent ontologies out there that you can just pull off the shelf for free. That might be a great place to start a more well-scoped POC to see if that can help you resolve some of your problems. Big thing, don't try and fix everything at once. Pick something small that you can try and use the knowledge graph for, see if it's for you, see if that makes you more responsive in that scope domain, and then you can build it out over time. I've seen too many companies try and do too much at once, and it's a nightmare. All right. So thanks for coming to this talk. I'm looking at the questions here. If anybody has a question they would like to ask, let me know. Otherwise, my contact info is here. My slides will be shared after this talk. You could be watching this as a recorded talk and you could freeze it. Feel free to shoot me an email. Love to talk about these sorts of things. You're welcome, Song. So anyway, in the last minute or so, throw a question in the chat if you have one. Otherwise, I hope you all have a fantastic day. Oh, you're welcome, Michael and Chris. Maybe I should have had a more pointed question because otherwise I'm just going to be staring at the camera for the next 30 seconds. Oh, thanks, Rory's in the chat. Special thanks to Rory. I should have given you a special slide here, Rory. She suffered through me giving a much worse version of this talk yesterday. At least I hope the talk yesterday was much worse and that I improved as a result. You're welcome, Angelique. All right. Well, apparently I was very clear, and there are many thanks. So you're very welcome. Hope you all have a great day.